8.4, scale factors and areas of 2D shapes. Okay, so here I have a ring. Maybe this is a washer. Okay, the radius of the outer is 2, the radius of the inner is 1.2. I want to know the area of the shaded region. So first I want to know here, and then if I doubled, if I took this and I made it twice as big somehow, so I make it twice as big, tell me about the area. Does the area double or what happens? Okay, so let's go through what they did here. So first of all, I said, oops, I said the area of the larger circle. So area of a circle is pi r squared. So the larger circle is going to be pi times 2 squared, and that's 12.56. So if I took the area of the whole bigger circle, then I took the area of the smaller circle, okay, and I got 4.52. So to find the area of the shaded, if I took the area of the big minus the area of the small, I'd only be left with what's shaded. Okay, so I do that and I get 8.042. Okay, now what I'm going to do is I'm going to double. So that means my outer is going to be 4 and my inner is going to be 2.4. So watch this. I'm going to go through those calculations. The area of the larger is 50. The area of the smaller is 18. I subtract them and I should get twice as much as 8. Maybe do I get 16? Wait a second. 50 minus 18. There's no way that's 16. That's actually 32. Interesting. Okay. So this is 4 times as big, not double. Okay, so your intuition might lead you astray here. It's not twice as big, it's 4 times. And we're going to learn exactly how we figure out how many times bigger it is. So just some important formulas. Area of a triangle is 1/2 base times height. Rectangle, square, parallelogram, trapezoid, and circle. And this would be something that I'd spend a second writing on a piece of paper because you can bring a piece of paper into the test. So having all these area formulas. Okay, let's look at another example here. So we have Jasmine making a kite from a 2 to 25 scale diagram. The area of the scale is 20 centimeters squared. How much fabric does she need for her kite? So it's a 2 to 25. So let's look here. So she said the scale factor, it's 25 to 2. So her normal one's 25. Her scale diagram is 2. So it's 12.25. So I know that it's an enlargement. The kite is bigger than the diagram. Makes sense. Big kite. Okay. So my scale factor is 12.5. So the area of the kite is equal to k squared of the area of the scale diagram. This is new. So I take my scale factor and I square it because area has meters squared. It's squared units. Okay? Area of the smaller is equal to area of the kite, the bigger thing, is the scale factor squared times the area of the scale diagram. So I have the scale diagram is 20. I would just have to times it by 12.5 squared. Okay? And that's all there is to this section. Okay, let's look at the summary here. If 2D shapes are similar and their dimensions are related by a scale factor, then the relationship between the area of the similar shape and the original shape is the similar shape is equal to k squared times the original shape. If the area of a similar 2D shape and the area of the original shape are known, then the scale factor can be determined using the formula. K squared is equal to the area of the 2D divided by the area of the original shape. Okay, good idea to do lots of problems here and use your intuition. Which one should be bigger, your scale factor or your scale diagram? Well, it depends if it's an enlargement or a reduction. So doing lots of questions, you're getting exact values here. Check your work.